To determine if a 45 kVA 3-phase 480 delta to 120/208Y transformer can adequately supply a 225 amp 3-phase lighting panel that feeds only single-phase loads, a series of calculations must be performed. These calculations will compare the transformer's capacity with the panel's demand. The transformer's apparent power rating is 45 kVA. The transformer's phase voltage on the delta side is 480 volts. To calculate the line voltage on the delta side, which is relevant to the transformation ratio, we multiply the phase voltage by the square root of 3. Thus, the line voltage equals the square root of 3, approximately 1.732, multiplied by 480 volts, which equals 831.44 volts. The panel load is characterized by a current of 225 amps and a single-phase voltage of 120 volts. For simplicity and to represent a typical lighting load, we will assume a power factor of 1.0, which is unity. Firstly, let's calculate the transformer's single-phase output voltage. Given that the transformer is a 480 delta to 120/208Y configuration, the 120-volt single-phase output is derived from the line-to-neutral voltage of the Y connection. To relate this to the delta side, we consider the turns ratio of the transformer. However, for direct comparison, we'll use the calculated delta line voltage of 831.44 volts. The single-phase voltage, reference to the delta side, can be found by dividing the delta line voltage by the square root of 3. Therefore, the single-phase output voltage is equal to 831.44 volts divided by the square root of 3, which is approximately 1.732, resulting in 479.64 volts. Secondly, let's calculate the transformer's single-phase output current. This is determined by dividing the transformer's apparent power by the product of the voltage, the square root of 3, and the power factor. The apparent power is 45,000 volt amps. The voltage used in this calculation is the previously calculated single-phase voltage of 479.64 volts. The power factor is 1.0. Therefore, the single-phase output current is equal to 45,000 volt amps divided by the product of 479.64 volts, the square root of 3, and 1.0. This results in a current of 57.92 amps. Thirdly, let's compare the transformer's output current to the panel load current. The transformer's calculated single-phase output current is 57.92 amps, while the panel load current is 225 amps. The question then becomes, can a 45 kVA transformer with a calculated single-phase output current based on the initial voltage ratio and 3-phase configuration of 57.92 amps handle a 225 amp load on the secondary side? This simple comparison of the 57.92 amps and 225 amps is incorrect and requires further clarification. The error in the calculation lies in directly comparing a single-phase equivalent current derived from the transformer's kVA rating and a line-to-line current of the panel. A more accurate assessment requires considering the total power demand of the panel and comparing it to the transformer's rated capacity. The panel's load is 225 amps at 208 volts 3-phase. The apparent power S in volt amps is calculated using the formula S equals the square root of 3 multiplied by the voltage multiplied by the current. S equals square root 3 asterisk volts asterisk amps. Substituting the values gives the square root of 3 multiplied by 208 volts multiplied by 225 amps. S equals square root 3 asterisk 208 volts asterisk 225 amps equals approximately 81,067.74 volt amps or 81.7 kVA. This means the panel requires 81.7 kVA. Since the transformer is only rated for 45 kVA, it is significantly undersized for the load. The conclusion is that the 45 kVA transformer is not suitable for feeding the 225 amp panel, even if the panel is only feeding single-phase loads. The transformer lacks the necessary capacity to handle the total apparent power demand of the panel. Therefore, a transformer with a high kVA rating is required to meet the load demands of the 225 amp panel. The initial calculation was misleading because it attempted to directly compare calculated single-phase current based on the transformer's three-phase rating to the panel's amperage. A proper assessment involves calculating the total kVA required by the panel and ensuring the transformer's kVA rating meets or exceeds that value.